Hey everyone. So today, we're diving into some really fascinating research from DeepSeek AI that kind of flips a big assumption on its head. We've all been thinking that a smarter AI needs more and more processing power, right? Well, what if the real key isn't a bigger brain, but a perfect memory?
So let's start with that fundamental question. How do we actually make an AI smarter? For the longest time, the answer seemed pretty straightforward. You just give it more power, you feed it more data, basically you build a bigger brain. But this new research explores a different path, one that might be a lot more, elegant. You can really think about this in two ways. On the one hand, you've got more computation. This is where the AI's brain just thinks harder. And that's the whole idea behind popular methods like mixture of experts. But then there's this other path, a less traveled one, smarter memory. Instead of just thinking harder, what if the AI could simply remember better? And that question is what sets up this entire breakthrough.
Okay, so to really get why this new memory idea is so exciting, we first need to understand the current champion of scaling up AI, this thing called the mixture of experts model.
Mo is honestly a super clever concept. Instead of having one gigantic brain that tries to do everything at once, you have a council of smaller, specialized brains, or experts. So when a task comes in, a little router sends it to the best expert for that specific job. This is what we call conditional computation. You're only spinning up the parts of the brain you actually need. Pretty efficient, right?
But notice that key word is still computation. The expert still has to calculate the answer, basically from scratch. And that got the DeepSeek researchers thinking, what if, for a lot of common problems, the AI doesn't need to calculate an answer at all? What if there's another way?
And that simple question leads us straight to the heart of this research, a totally new path to efficiency that they call conditional memory. Okay, so here's the core idea, and it's super intuitive. If I ask you, what's the capital of France? You don't calculate it. You don't reason it out from first principles. You just know it's Paris. You retrieve it instantly from your memory. Well, conditional memory gives an AI that exact same power, the ability to just look up knowledge it already has, instead of wasting precious energy figuring it out all over again.
This creates what the paper calls a new axis of sparsity. Now, sparsity is just a fancy way of saying efficiency, doing more with less. Think of it this way. Mixture of experts made things efficient by only using some of the AI's computational power. Conditional memory adds a whole new dimension of efficiency by only using memory when it's needed. It's like adding a second really powerful tool to the AI's toolbox.
Now, if you're going to have a system like this, a huge library of knowledge, you need a gatekeeper. You need someone to manage it all. And in this model, that role is played by a module they named Engram. Just think of it as the brain's hyper-efficient librarian. Now, without getting too deep in the weeds here, Engram is basically a supercharged version of an older idea. The really key part is something called O1 lookup. All that means in simple terms is that its retrieval time is constant. It is crazy fast. So it doesn't matter if the AI's library has 1,000 facts or 1 billion facts. Engram finds the right piece of info instantly. And you can see how it works in action right here. So as text comes into the AI, the Engram librarian is watching. It spots a familiar phrase or a common pattern, and bam! It instantly pulls that data from its memory bank and fuses it right into the AI's current line of thought. It's like having a perfect research assistant working at the speed of light.
Okay, so this all sounds amazing in theory, but does it actually work in the real world? Does giving an AI a perfect memory actually make it better at complex stuff like reasoning and coding? Well, let's see what the data says. The results are, they're pretty staggering. I'm actually going to read this right from the paper because it says it all. The model demonstrates consistent improvements over MOE baselines across knowledge, reasoning, code, and math domains. So let's be clear. This isn't some tiny little tweak. We're talking about a major performance boost across the entire board. And what's really important is that they made sure it was a fair fight. The Engram-powered model went head-to-head with a standard model of the exact same size, and it was given the exact same amount of computational energy to use. So it didn't win by being bigger or stronger, it won by being smarter with its resources.
But here's where it gets really, really interesting. One of their key discoveries was that there's a sweet spot. You can't just throw infinite memory at the problem. They found what's called a U-shaped scaling law, which basically means there's a perfect Goldilocks-style balance between how much of the model's brain power is used for computation versus how much is used for memory. If you get that balance wrong, performance actually drops. But if you get it just right, that's when you unlock these huge gains.
And all of this brings us to what is, I think, the most profound takeaway from this research. Because this is about more than just getting better scores on a test. It's about fundamentally changing how an AI uses its brain power.
So what's really happening under the hood? The analysis shows that the Engram memory module handles all the boring, repetitive tasks. It takes care of things like basic grammar, common bits of code, or just frequently used facts. It's basically handling the AI equivalent of rote memorization. And by offloading all of that grunt work to its instant lookup memory, something pretty incredible happens. It frees up the AI's core thinking layers, what's called its effective depth, to focus only on the hard stuff. It doesn't have to waste energy remembering things, so it can dedicate all of its power to reasoning, to logic, to actual problem solving.
So we're left with a really fascinating question. For years, the big race in AI has been about building a bigger and bigger brain. But this research points to a powerful new direction. Maybe, just maybe, the true path to a smarter, more capable AI isn't just a bigger brain, but a brain with a perfect instant memory.